In today's lesson, I'm going to talk about nature of the roots of a quadratic equation. So how can we find how many roots we have without solving quadratic equations? So the first equation we have is x squared minus 3x minus 10 is equal to 0. And we have to figure out how many solutions are there and how is it related to the discriminant rule or equation. If you remember, the discriminant rule is we have x is equal to negative b plus minus b squared minus 4ac divided by 2a. This is called the discriminant formula. So to find out how many solutions are there, so if I just graph this equation, y is equal to x squared minus 3x minus 10, and if I graph this, you can see from the graph that we have two solutions of this quadratic functions. The solutions means the roots or x-intercept. So this graph intersect x-axis at two places. So this has two roots. So using GDC, we know that this has two roots. Now I'm going to also find out for this what is a, b, and c. So a is 1, b is negative 3, c is negative 10. So b squared minus 4ac, which is the part which you have under square root. And first thing is that let's find out how much is the value of b squared minus 4ac in this case. So this becomes negative 3 whole square minus 4 times 1 times negative 10. And you get 9 plus 40, which is 49. So this number, which we got as b squared minus 4ac is equal to 49, is positive, is greater than 0. So, and we had two roots here, and we know b squared minus 4ac was greater than 0, and we got 2 and two distinct roots in this case here. Real roots, yeah? So we are talking about real roots in this case. Now similarly, we can do x squared minus 12x plus 36. Let's graph it to see how many solutions we have here. Minus 12x plus 36. And if I graph it, then I can see from the graph that this graph touches the x-axis at one place, which means it has only one root, which is a repeated root in this case. Now let's find out what is our b squared minus 4ac in this case. So a is 1, b is negative 12, c is 36. So b squared minus 4ac is negative 12 whole square minus 4 into 1 into 36, and you get 144. So here the value you got is 144 minus 4 times 36 is equal to also 144. So you get this value as 0. So in this case, so this is equal to, both of them you got here is equal to 0. So in this case, if you remember, the graph looked like two intercept. I don't remember exactly, but it was crossing x-axis at two places. In this case, the graph looks like, we can still see that graph. So here 0, 1, 2, and 3. So the graph touches the x-axis at one place. And b squared minus 4ac is equal to, in this case, was 0. And we had repeated roots in this case, or one root. Okay, so when b squared minus 4ac was positive, this is called nature of root. Nature of root means the nature of roots. Nature of the roots means one root, two roots, or no real roots. So this is called the nature of the roots. Okay, let's move to the next example here. So here we have 3x squared minus 2x plus 5. So using b squared minus 4ac, in some textbook they use d as a discriminant, and or you can use this as lambda, which is b squared minus 4ac. So in this case, when a is 3, b is negative 2, c is equal to 5. So b squared minus 4ac is going to be 9 minus 4 into, sorry, this will be 4 minus 4 into 3 into 5. So you get 4 minus 60, which means you get here a negative number here. So 3x squared, this is negative, which means no real root. And how will the graph of this look like? Let's sketch this graph, and we can see from here. So it's 3x squared minus 2x plus 5. And if I graph it, you can see the graph of this function will not intercept on x-axis. So which means there is no real root. So the graph is like that. Okay. So the conclusion for this one is, if you have d greater than 0, then which means it has two distinct real roots. If you have d is equal to 0, which means it has one repeated root. And if d is less than 0, there is no real root. There will be roots, but not the real roots. Okay. Now again, without solving, so whenever they ask you for the nature of the root, they are not asking the value of x. That's why it's asking in the question without solving quadratic equation. We have to determine the nature of the roots. So the nature of the roots is determined by discriminant, which is b squared minus 4ac. So first step, write down a is equal to 5 in this case, b is 7, c is negative 5. So b squared 7 squared minus 4 into 5 into negative 1. 49 plus 20, 69, which is greater than 0, which means two distinct real roots. Now this one, first thing, we need to rearrange and put it in standard form. So x squared term first, then x term, and then you have constant term. So a in this case is 25, b is negative 70, c is 49. You can use calculator to do all the calculations here, since the numbers are big. So you will get 4900 minus, 490. It's not that hard. You can do by hand as well. So 0, which means one real root, which is going to be repeated roots in this case. Okay. Let's do a couple of more examples here. So next one is 2x squared plus 7 over 4x plus half equal to 0. So rather than starting with a is 2, b is 7 over 4, c is half, what I'm going to do is I'm going to get rid of this fraction first. So I'm going to multiply everything by 4. So this is 8x squared plus 7x plus 2 is equal to 0. Now my a is 8, b is 7, c is 2. So b squared minus 4ac in this case is 7 squared. 4 into 8 into 2, 49 minus 64. So you get negative number here, which is less than 0. Okay, which means there are no real roots in this case. Next question is you have to find the value of p. P in this case is a constant term, which is not given. But what is given here is that it has two real roots. Now it has two real roots means we know b squared minus 4ac has to be 0. And now a is 2, b is negative 3, c is p. It's very important that you write down what is a, b, and c to avoid any calculation mistakes. So negative 3 whole square minus 4 into 2 into p must be equal to 0. So 9 minus 8p is 0. 9 is equal to 8p. So p is equal to 9 over 8. So p is equal to 9 over 8 is your value here. Has two real roots. Sorry, it's two real, not one root. So that should be greater than 0. So that's greater than 0. So the condition will change. So pay attention to what they are asking in this. So p has to be less than 9 over 8, which means there are lots of possible values for this p. To have this quadratic equation has two real roots. So just one more time, b squared minus 4ac is greater than 0. So pay attention to make sure that you remember those conditions correctly. Next is px squared plus p is equal to 13x. 13x has one real repeated root. Now the condition is b squared minus 4ac is equal to 0. Again, rearrange it, write down in a standard form. So x squared term first, then x term, then the constant one. Now your a is p, b is negative 13, c is p, and now b squared minus 4ac is equal to negative 13 whole square. 4 times p has to be 0. 169 is 4p square. So p square is 169 over 4. So p is equal to plus minus 13 over 2. So that will give you one repeated root in this case. Okay. Let's move to the next example. This has no real root now. And again, first thing, we need to rewrite this. So this is 2px minus, I'm going to just write down 1 minus p here, or I can do p plus 2x squared plus 2px plus p minus 1 equal to 0. And I can put p minus 1 in a bracket. So when you open this, this is negative 1, this is p. Now a is p plus 2, b is... your b is 2p and c is p minus 1. Use the bracket whenever you have more than one terms. It's always recommended that you use a bracket. Now the discriminant is b squared minus 4ac. No real root means has to be less than 0. So then you have 2p whole square minus 4 into p plus 2, p minus 1 less than 0. Now let's open it. Minus 4 into, this is equal to p square minus p plus 2p minus 2 less than 0. We can actually get rid of 4 here, and we can simply have p square minus p p. This becomes plus p minus 2 less than 0. Less than 0. This get cancelled. So minus p less than minus 2. When I divide or multiply the inequality with a negative number, the inequality sign will change. So p has to be greater than 2. Okay. In this case, because if I took 4 common and we have right hand side as 0, so if I divide everything by 4, 0 over 4 is 0. So that's why I could get rid of this 4. Okay. The next one is when you have to find the value of r when you have x squared plus 3rx plus 1 is equal to 0. And then the different conditions, for different conditions, you have to find the value of r. The first condition is 2 distinct real roots. Again, for 2 distinct real roots, we know b squared minus 4ac has to be positive. For 1, b squared minus 4ac has to be 0. For no real root, b squared minus 4ac less than 0. So let's start with a is 1, b is 3r, c is equal to 1. So b squared minus 4ac in all the cases is going to be, I can write down that once and then I can use the conditions. 3r squared minus 4 into 1, 9r squared minus 4. So for the first one, real roots, 9r squared minus 4 has to be greater than 0, 9r squared. So in this case, what I'm going to do here is I'm going to factorize it. And then I got r is 2 over 3 and r is negative 2 over 3. This is not the only way, but I'm doing it using the sign diagram here. So this is negative 2 over 3. This is 2 over 3. Now we need to find in which, what value of r satisfy this equation. So now here I can use 0. And if I substitute 0, you don't have to find the values, just substitute 0 in this one and see whether it gives you negative or positive number. So you can do in your mind. So this is negative here. So greater than 2 over 3, I'm going to use the simple number. So let's use 1. So when it's r is 1, it gives me positive. Here, when r is negative 1, it's again going to give me positive, which means the solution for this one is r is less than negative 2 over 3 or r is greater than 2 over 3. Okay, or in other words, you can say is absolute value of r is greater than 2 over 3. Up to you, but this will be the solution in this case. The next one is the repeated root. So you just simply do equal to 0 is 4, r squared is 4 over 9. So r is equal to plus minus 2 over 3. Then b squared minus 4ac less than 0. That is 9, r squared minus 4 is less than 0. This is less than 4. R squared is less than 4 over 9. Again, you can do this way, or I already did actually the sign diagram here. So we can use the same sign diagram and you can see where this equation is less than 0 and that region in this case is negative 2 over 3 less than r less than 2 over 3. So this is not required here. So that is the for the value of r. When you have two distinct real roots, then r is less than -2/3 or r is greater than 2/3. When it has one repeated root, r is plus minus 2/3. When this is less than 0, then r is between -2/3 and 2/3. That's it for this lesson. Thank you.